In our last video, we built a right triangle from 2 points to find the distance between them using the hypotenuse. Today we ask a different question. What if, instead of the hypotenuse, we just look at the ratio of the two legs, the vertical leg over the horizontal leg? That ratio has a name. It is called slope. Steepness is measured as rise over run, how much you go up divided by how much you go across. Let's reuse the exact same right triangle from before, with the same 2 points, point 1 at x sub 1, y sub 1, and point 2 at x sub 2, y sub 2. The horizontal leg, the run, has length x sub 2 minus x sub 1. The vertical leg, the rise, has length y sub 2 minus y sub 1. Watch both the flat 2D triangle and the tilted 3D version. The legs are the same two quantities we used before. So the slope, which we call m, is defined as rise divided by run. That gives us the formula m equals open bracket y sub 2 minus y sub 1, close bracket, divided by open bracket x sub 2 minus x1, close bracket. Now here is a question before I show you the answer. Suppose I pick two completely different points further along the very same straight line and build a new right triangle. Will the slope I calculate from this new pair of points be the same as before or different? Pause here and make your prediction. Here is the reveal. The two triangles, the small one and the large one, are similar triangles. They share the same angle where the line crosses, and their sides are all parallel or lying along the same line. So every side of the big triangle is just a scaled up copy of the small triangle. Because the triangles are similar, their sides are proportional. That means the big triangle's rise divided by the big triangle's run equals the small triangle's rise divided by the small triangle's run. Look at the 2D and 3D views side by side. The scaling factor cancels out completely. And that is exactly why slope is called constant along a straight line. No matter which 2 points you pick on the line, the ratio rise over run always reduces to the same number, m. A sign error here would be forgetting to keep y sub 2 minus y sub 1 and x sub 2 minus x sub 1 in the same order. If you flip one and not the other, you get the wrong sign for the slope entirely. Now, a straight line has one slope everywhere, but what about a curve? A curve is steeper in some places and flatter in others, so there is no single slope for the whole curve. Instead, mathematicians ask, what is the slope of the curve at just one single point? The idea is to zoom in so close to that one point that the curve looks almost like a straight line, and then apply this exact same rise over run idea to find its slope there. That instantaneous slope is called the derivative, and finding it from scratch is exactly what we will do in the next video. Derivative from first principles. If this helped connect the dots between distance, slope, and the derivative, give the video a like and subscribe so you don't miss the next one, where we take this slope idea and zoom all the way into a single point on a curve.